Hello. So in this equation, it is given that alpha is equals to lambda times of theta, where alpha is angular acceleration and the theta is angle. And this lambda is a positive constant. So basically, here the angular acceleration is not a constant, it is a variable. It depends upon the theta, angular displacement. So in this equation, we have to calculate omega, which is angular velocity, as a function of theta. Okay. So if you see in this equation, alpha is not constant, so we cannot use kinematical equations, fixed kinematical equation. We have to go for differential kinematical equations. And if you remember, we have one, in this case if you see, we have this alpha, we have this theta, we have this alpha, we have this theta, and we have this omega. So basically, we have to replace this alpha by omega. So we need a differential equation which should have alpha, omega, and theta. In that case, we can make the relationship. And if you think about this kind of differential equation, we have one. And the differential equation which involve alpha, omega, and theta is this. So alpha is omega d omega by d theta. In this differential equation, if you see, alpha is there, theta is also there, and this omega is also there. So in this equation, we'll be able to easily replace this differential equation into this one. Okay, this is our question basically. So let's replace the value. If I replace the value, if I replace this alpha in this equation, we'll be getting omega d omega by d theta, and that is given as lambda times of theta. This lambda is not a variable, it is a constant. So it will remain in our equations. Okay. So in this equation, if you see, we are seeing two variables. Omega is one variable and theta is another variable. So what we can do here, let's first separate the variable first. So let's separate the variable. We'll do the separation of variables. If we separate the variables, we'll be having omega d omega on the left hand side, and the d theta I'll take on the right hand side. So it will be lambda times of theta d theta. Okay. So we have separated the variable. All we have to do is integrate this. So upon integration, if I do integrate this equation, then omega d omega, integration sign, lambda we will take out of the integration sign because lambda is a constant, will be equals to theta d theta. Okay, so if you see here, when the theta was 0, alpha is also 0, and you see we are calculating omega as a function of theta. So in the question it is given, initially omega was 0. It might be, sometimes they might give you initial some non-zero values on omega also. There will be no problem because when you are writing the lower limit value of theta, which is 0, here also you have to write the lower limit values of omega. So in this question it is 0. It might be non-zero also, it will not change the fact. Solution will not change, the answer will change there. Upper limit, we always put the variable upper limit. I'm putting it theta, and here I'm putting variable as omega. Okay. So now let's integrate this. So if I do integrate this omega d omega, integration of omega d omega is omega square by 2. Limits from 0 to omega. And integration of theta d theta, I think you know that, it's same as theta square by 2, 0 to theta. First we'll put the upper limit in this, and let's say this 2 is here, 2 is here, they can cancel out. So we'll put the upper limit, that will be equals to omega square minus lower limit, which is 0. That will be equals to lambda times of upper limit theta square minus 0. And that will make omega is equals to under root of lambda times of theta. And obviously it will be plus minus. It can have a positive value, it can have a negative value, but the thing is, we are talking about the magnitude. And magnitude wise, because there is no direction here, magnitude wise, they have to be positive. Okay. So that's how we solve. Whenever the alpha or anything is given in terms of variable, we have to integrate, and that's how we integrate. We use the differential equation. In total, we have 4 differential equations. While integrating, we have to think about the quantity given and the quantity we have to calculate. So any differential equation you are using, there that differential equation should consist the quantities which are given and the quantities we have to calculate. Okay. So that will make it easy to solve these questions. Okay, thank you.